Clear. Okay, this is the appearance of the machine. We have 18.5. Sorry?
Buna konuştuk. Şey olmalıydı. Adam hangisi? Platform diktatörü. Platform diktatörü ve oksidasyonu yapımını kabul etmemişti. Yanlış bilmiyorum. Böyle katılıyorum. O benim düzenlemem mi?
Excuse me?
Bir şey yaptı. Adam şey itiraz etmiş. Ondan böyle şey yaptı.
Bahasa Indonesia aku ini mute. Taiwan hari ini.
Yeah, okay, this is the appearance of the machine.
Akalanya kasi
We have 18.5 inch touch screen and this gesture touch screen, our capacitive touch screen, which have gesture feature. So that's mean you can slide to the right, you will get a new window, and to the left as well, you will get a new window with the different waveform, for example. And also you can slide it down to discharge the patient, for example, similar to the patient monitor. Okay, to the N-series patient monitor. Okay, we don't have any resistive touch screen in the A9 or A8. It's only capacitive touch screen. Okay, and here the electronic flow control. Here we have the HFNC module or auxiliary air auto module. Okay, or auxiliary air auto supply. Sorry, and here we have the integrated suction. We have the breathing system or the breathing circuit. We have the CO2 canister, and we have the ACGO also. Working light below the screen. Okay, so sometimes the anesthesiology call this table is a writing table. So they will just switch on the working light and they will write some patient information, for example, or patient history or whatever record they can write it on this table. Okay. Here the electronic vaporizer, backup flow control system, door. Okay. This, if there is a problem with the AFCS, automatically this door will open and the PFCS will work. Okay. We'll go to this side when we present the service training. Okay. This is the system switch. This is the gas supply gauge. Okay, or the pressure indicator of the gas supply. And here is the handle, the drawer, central brake system, and the foot rest. Okay, this is the device from behind, or the rear view of the device. We have the auxiliary AC connector. We have the main inlet or the main power connector. Okay, and we have this hooks for cable management. We have the cylinder yokes, and we have the pipeline connector. Here we have the ground connector for example, this is the ground connector of the machine, and if you are going to make the electrical safety test, for example, so you will connect to the ground point here. Here we have the communication port, VGA, and also the USB connector. We have the hooks, we have the overfill protection cap for the Venturi suction or for the suction if it's a vacuum pipeline suction. And here we have the waste gas or scavenging connector. We have the liquid collection button for the suction. Okay, here this is the mount for the GCX arm, let's say. And here this is the HFNC outlet. So this HFNC outlet will be connected to the humidifier. Okay, and then it will go to the patient nasal cannula. Okay, to the patient. Here this is the hook for the tube of the HFNC mainly. And also here the module, the HGSS flow control knob. So we are setting the highest flow at the service menu, and then we can control it from here. Okay. And it depends on the hospital flow of the AGSS. So if the hospital is higher than our machine or lower than our machine, we can adjust it to suitable range of the hospital. Okay. Here is the sample gas return, and here is the high pressure outlet. What's the high pressure auto outlet? Sometimes there is another peripheral device need to be connected beside our machine. So in here, it can give me similar output of the gas supply, of the wall gas supply. So it's like extension from the wall gas supply. So, and by we will connect one hose to the other devices. whatever device, what's peripheral device need gas supply or need oxygen supply can be connected by the hose to this outlet. Okay, is it clear? Sorry? Yeah, if you are connected also flow meter, for example, you can just put the flow meter in the side rail and connect the hose from here. Okay, here is the monitor, or in the display of the device, we have the button for the working light switch. Okay, and we have the working light. We have the GCX rail for monitor arm, let's say, and we have the handle or side rail, and we have also other mounting rail. Okay. This is the drawer, and we can up and down limit for the drawer to avoid any broken. So the upper limit is 45, and from upper and down limit from 15 to 45 degree. Move out of range might cause damage of the drawers. Okay, and this is also the monitor of the device. It's also rotatable, and you can move it up and down as well. This is the working light, and this is the working table as per the anesthesia result. Okay, this is how you connect the HFNC to the humidifier, and then to the nasal cannula to the patient. Okay, we have multiple connectivity options to the side rail of the device. Like for example, if we are connected the N-series patient monitor, and we are using, for example, iView screen can be inserted here, or if they are using also independent screen, they can put it here as well. Is it clear?
Loud and clear.
Where do you use the humidifier?
The humidifier?
Yeah.
It's mandatory to be used in the HFNC, in the high flow nasal cannula, because you are getting here. If you want to get 60 liter per minute of oxygen flow, you can use the pure oxygen to get 60 liter. If you mix it with the air, you are able to reach up to 100 liter per minute. Okay, and this is actually, it's dry gases, so you have to humidify it. That's why you are using the humidifier.
Okay, thank you.
Yeah. Okay, here the breathing system. Classic breathing circuit, panel designed with ABL, auto manual switch, pressure gauge, inspiration, expiration, unidirectional valve, and pre-pack CO2 canister. Okay, heating for whole breathing system, clear indicator illumination of ABL to indicate the manual mode, ABL quick release. Okay, so what's the difference between the heating system of the A9 and the A7, let's say? Do you know any difference?
Can you come again?
What's the difference between the breathing system of A9 and A7, let's say? Do you have A9?
In the A9 there is a volume exchanger, and in the A7 there is below.
Yeah, this is the ventilator. Okay, for the breathing system, mainly, if you are going to make like the leakage test of your A7, okay, you have to make the O2 and then switch it to manual to make the manual leakage test as well. In the A9, we have micro switch inside, so no need to switch from auto to manual. It's automatically detected. So the machine will go to do the auto leakage test, and then by itself it will go to do the manual leakage test. So no need to switch from manual to auto during the leakage test. Okay, and about the illumination of the ABL, here is the illumination in the blue color. Okay, and about the quick release. Okay, so if you need to release the bag pressure, you will just pull up the ABL valve. This is the quick release feature. Is it clear? Guys, what's the pre-pack CO2
Yes,
canister?
it's clear.
what's the benefit from the pre-pack CO2 canister? You know, we have also disposable CO2 canister. So pre-pack, that means it's already packed before. Okay, so you just remove the packing and install this canister. This is the pre-pack feature. Okay. So do you know what's the bypass assembly?
Canister.
We'll go through it. Okay.
What's your question?
Pre-pack
What's
CO2.
the bypass assembly of the canister?
Bypass. During the previous
If
check,
you
you can.
remove the canister,
Previous check, you can.
or
can-
if you remove the canister, the circuit is still closed.
Yeah,
Yeah.
that's right. Yeah. So the bypass assembly is that it's the feature that enables the doctor to change the soda lime during the surgery without leakage. Okay, the circuit will still closed. Yes. Okay, so this is the absorbent and compatible with loose fill and the pre-pack absorbent. We have two types of this canister, loose fill or pre-pack. Okay, and quick remove the absorbent and condensate water at the same time without tool. So no need for any tool to remove the canister. You will just switch off the handle and remove the canister. Replacement of absorbent is allowed during the surgery CO2 bypass because we have the bypass assembly here. So bypass allow the doctor to remove or to change the soda lime or to refill the soda lime during the surgery without leakage. Okay.
What's the, excuse me, what
Yes.
is the difference between loose fill and pre-pack?
Loose fill and pre-pack. Actually, pre-pack, that means it's disposable soda lime canister. Okay. We call it pre-pack because suppose this canister will come packed already and you'll just remove the pack and install the canister. There is the part number of accessories for the pre-pack soda lime canister. Okay.
So in the picture, it is pre-pack or loose fill in the picture?
Also, they call this one pre-pack, but actually pre-pack will come without this handle. Okay. It's only the canister packed. You will just remove the pack and install it. Loose fill for the old devices also they have like a canister. It's not a pre-packed. Okay, that's the one which we call it loose fill. It's different shape, by the way. It's not similar to this one. So this one also they are calling it pre-pack. It's different shape, similar to the Watu or to the A7, the old one. This is the loose fill. But rarely you will find this configuration
okay,
with the A9.
I know
Yeah.
it.
Yeah, it's very rare you will find this configuration with the A9. Mainly A9 will come with from the manufacturer with the pre-pack set or with the bypass assembly set as well. Here?
Loud and clear.
Yes, please.
Okay. So here the most important feature of our A9 or A8 as well, we have the volume exchanger. So what's the benefit from the volume exchanger? This replaced the
Billows.
billows.
Yes.
Okay. So what's the benefit? Quick wash in and wash out by small system volume and precise ventilation for all the patients from adult to neonate with tidal volume down started from 5
ml
and
to
0
0
pip.
pip.
You know, in old anesthesia or on the pillows anesthesia, it's impossible to reach the 0 pip. Why? Because the pillows will not go to the base. There will be some rubber, okay, and it has some pressure. Is this clear?
Yeah, because there is some.
Yes.
Yeah, so you will never reach 0 pip with the pillows anesthesia.
Billows, yes.
Even GE.
All anesthesia, I think.
Yeah, so this is an important feature of the volume exchange that we can reach the 0 pip. And the tidal volume started from 5 ml. Showing the
ml.
state of breathing system clearly by visual volume exchanger indicator. This is the one in the administrator screen. We call this one administrator screen. Okay, so it will show the inspiration phase as well the expiration phase. More reliable and less risk of malfunction with no moving component,
Yes.
providing extremely reliable and greater service life.
What do you mean
Uninterrupted
by
ventilation.
quick wash and wash?
Quick wash and what?
This is
okay.
autoclave.
Yes, autoclavable this one.
What do you
No,
mean
no,
by
no, no.
quick wash?
No, washing out of the gases.
Okay.
Washing out of the gases. For example, if you want to wash out the volume exchanger, you will press the auto flush, and it's easily washing out because there is no mini component inside. It's not like the pillows. This is the meaning of wash out. Okay. Uninterrupted ventilation when excessive leakage.
Why do we need zero PEEP?
It depends on the patient situation. Sometimes the doctor decides to make zero PEEP for the patient,
Or neonatal.
or for neonatal. Yeah, it depends on the patient situation. So it's a clinical feature.
Physiologically, zero PEEP is like a dead patient, yeah?
Sorry? No. Dasho, you hear about the intrinsic PEEP?
Yeah.
The intrinsic PEEP for the obese people. For example, some portion of the lung, due to the obesity of this patient, okay, it's closed and it has some pressure inside. So this is intrinsic PEEP. In this case, the doctor will try to minimize this intrinsic PEEP. So at that time, maybe the doctor decide to put zero PEEP because the patient already have built-in PEEP cannot be released from the lung. It is clear. And sometimes for ARDS patient, for critical situation of the patient, the doctor decide to put zero PEEP. Is this clear? Or for neonatal patient as well.
Okay.
So it depends on the respiratory complication or the situation of the patient. The doctor decide to put zero PEEP.
Okay.
Okay. And uninterrupted ventilation when excessive leakage happens. You know the pillows if it has excessive leakage more than 200 mm, okay, the pillows will go down and will not raise up anymore. Okay, and you will receive a lot of complaint from the customer that this pillows goes down, there is a problem, and actually it's only leakage happened during the surgery. Okay, so since this device has no movable part, okay, and it's only gases flowing in this volume exchanger. So even if there is excessive leakage, I already have my gas. Okay, I will consume a lot of gases, but at the end, I will not stop the surgery because of the leakage, similar to the Wato or to the A7. Is this clear?
Yeah, very nice design.
Yes.
So if is there a huge leakage, the machine will work normally?
Yeah, it will work. It will work normally, but depend also by what do you mean by a huge
It will
leakage?
compensate.
Like, for example,
There
if
is
the
a
leakage is
compensation.
1 liter, even with the flow of gases, I cannot compensate this leakage. But for leakage, if it happened more than 200, like let's say 400, yeah, they can continue the surgery with this. Okay, they will consume more gases, but they will not interrupt the surgery. Okay. So this is the pneumatic diagram of the volume exchanger. I prefer to let you see the video that I have. It will describe this more easily for you. Are you seeing my screen, guys, or it's only the presentation?
Presentation.
Yeah. Okay. No,
Presentation.
Okay.
Now the presentation.
just a moment. So now you are seeing the video now?
Yes.
Yes.
Yes. Yes.
No sound.
Just a moment. Hold on a second.
Dito pala on dyan yung ano eh.
Now we are seeing the king, guys. I'm sorry for this interruption.
Yes, yes. No problem.
Are you hearing the sound as well or no?
Still no sound.
No sound.
No sound.
No sound.
No.
Maybe he puts the mic with us.
No sound. Share audio. Share audio lang.
Okay.
Pero hindi tayo naririnig doon, no?
Even now, no sound at all.
Yes, no sound.
Inspiration.
What is this driving gas? Oxygen or air?
Yeah, it's oxygen. Okay. It's oxygen, and it's actually, if there is a problem with the oxygen, or the oxygen is going below 125 kilopascal, okay, it will automatically switch to the air.
Air. Okay.
Yeah. Sorry, I will solve the sound problem later, but you can see the video to see the operation
Okay.
principle
Yeah,
of this. Yeah.
You explain while the video is.
Yeah. Okay.
So this is the one who plays the bellow, huh?
Yeah. See, this is the driving gas. Okay, in the green. And this is the expired gas from the patient. Okay.
Why two line, not only one? One inspired, one expired?
No, it's not one expired and one inspired. For more efficient, that's only because, for example, do you know McKay flow eye anesthesia machine?
No.
McKay flow eye having the similar concept, but with one layer only. So they found that 2 layer is more efficient. So they designed it with 2 layer.
Okay.
Okay.
So you mean the pressed gas and the inspiratory of patient are mixing together?
Mixing together with the dry gas, no?
No, I mean the pressed gas, the one with anesthetic agent and the breathing of patient are mixing there.
It's not mixing because while the patient exhale,
Expiratory naman yun.
Yeah.
We mix
this
it.
blue is expired gas from the patient. Okay. So again, for the inspiration, it will pass to the soda lime canister and absorb the CO2 and then go to the patient again.
I'll go to patient again. Okay. Yeah.
Yeah, so the exhaled gas will go to the volume exchanger. Okay, and in the next inspiration phase, again, the drive gas will push this exhaled gas plus some more gases from the mixer, of course. Okay, and then it will go to the canister to absorb the CO2 from it, and then again will go to the patient. Is it clear?
Yes.
Okay. So someone will ask, is the drive gas will mix with the gases of the patient or with the fresh gas flow?
Yeah.
Here, less diffusion due to smaller contact area. So there is no enough contact area between these gases to mix up together. So this is smart design. So they calculate the diameter and the interaction between these two gases. So these two gases are not able to mix with each other. Okay, as you know, the bellows, the drive gas will be
Outside
the
the
upper
bellow.
side of the bellow. Yeah, outside.
Yes.
Yeah, outside the bellow. So for sure, because there is a diaphragm, it will not mix with the fresh gas.
Fresh gas. Yeah.
Yeah, and here also they calculate the spaces, which will prevent the mixing of the drive gas to the fresh gas.
Okay. So you mean the driving gas is the green one and the blue one
Yeah.
is the fresh gas?
Exactly. Yes. Yes.
Okay.
Yan na yung bilos niya.
Yung gas exchanger. Wala nang bilos yan eh. Gas exchanger na lang.
Excuse me, but as we see in the
Yeah.
video, there is no contact between the drive and the fresh gas.
How come?
It should be mixed. It should be mixed.
No.
Yeah.
The
There is a
bellows
less
also not
diffusion.
mixing.
Yeah, there is no space. There is no any diaphragm between both of them. But here you can see less diffusion due to smaller contact area between two gases.
Less diffusion.
Yeah. So the drive gas will not mix up with the fresh gas.
Now, in case of leak, is there anything happen that drive gas will go to patient lungs because of the leak?
Because of the leak, the machine will try to compensate, okay, but you're still monitoring both gases, which going and come back from the patient. And also we have in the A9, A8, we have the internal gas module. It's mandatory to be there in the A9.
Okay.
Okay, so we have two way of analysis of the gases, the internal one and the external one as well, the external gas module. Okay, so in case of leakage, yeah, it might, for the leakage compensation, there will be more oxygenation because the drive gas at the end it's oxygen. Okay, but all of these will be monitored by the gas module. So the user will be aware about this. And also in case of leakage, in the administrator screen, it will give indication that there is a leakage, that the machine is compensating a lot.
Okay.
Yeah, so the user will be aware as well.
Very nice design.
Yeah. So let's see the inspiration phase and the expiration phase. Here, this is the non-return valve. Inspiratory non-return
yeah.
valve. Okay,
Yes.
and here is the expiratory non-return valve.
Yeah. Where is the auto plus?
The auto flush.
Yeah. Oxygen flush.
Yeah, there is in the front of the table. There is auto flush.
But not connected in the diagram.
And the diagram here. No, I will
Yeah.
show it to you in the block diagram later on the service training.
Okay.
We will show it, yeah.
Auto mode.
Okay. So what will happen in the expiratory phase? So during the expiration, the machine will let the patient to exhalate, okay, until reaching the beep limit. Okay.
Yeah.
So the expiratory valve will be closed
Until
or
the
will be
limit.
open at the beep limit. Okay, whatever exceeded the beep limit will go to the AJSS.
Okay.
Got it? And in the inspiration phase, the expiratory valve also will be closed at the bow limit, the airway pressure, which is, let's say, 40 millibar or 50 millibar. Okay? So the expiratory valve in the inspiration phase will be closed. And the pressure limit of that one is whatever the doctor set the bow limit. Okay, so in case the doctor said, let's say, bow limit is 50 or 40, okay? So once there is more pressure than 40, for safety, the expiratory valve will release this pressure to the AJSS to avoid over-pressurize the patient. Is this clear?
Mm.
It will be more clear when we demonstrate the block diagram.
Yeah.
Yeah, it's very clear.
Why your APL valve is in the expiratory side?
The ABL valve in the expiratory side.
Yeah, for the bag.
No, it's located there, but actually it's not in the expiratory side.
Okay.
Okay. Of course, what's the APL valve? It's adjusted pressure limitation, right?
Yes.
Yeah.
Or a
So
manual. for manual
yeah. So I'm
pumping.
adjusting. Yeah, I'm adjusting the pressure of the manual bag. Okay, I
Yes.
will not. Yeah, if I increase the pressure than the adjusted and then the limit, this exceeded pressure will be released to the AJSS as well.
Okay.
Okay. So let's say I adjusted to 30 millibar, let's say, and I pressed of more than 30 millibar.
Yeah.
The exceeded pressure will be released to the AJSS.
Okay.
Okay.
This is the manual.
Yeah, manual mode. Still the manual mode is passing to canister.
Yeah, for sure, because what's the difference between the manual and automatic mode? The manual, the doctor is ventilating the patient manually. Okay, so for sure I have CO2 exhaled from the patient. That's why I need to pass by again to the
Yeah.
CO2 canister
Yeah.
to absorb
yeah.
the exhaled CO2.
Yeah. Yes.
And if you see, this is the APL limit. So this bag will inflate up to reaching the APL limit.
Yes. Up to 30.
Okay. Yes, up to 30, for example, whatever APL limit. Okay. Whatever exceeded pressure than the 30 millibar, it will be released to the AJSS.
Okay. Very nice design.
Tubing.
Yeah, see? So this is the administrator screen of the device. It will give you a clear or correct indication of the tidal volume delivered to the patient. See, if there is a leakage, here the administrator screen will indicate the leakage. So the doctor will be aware that there is some leakage problem and they will try to fix the tubing or whatever, but they will continue the surgery. But this indication that the machine will consume more gases to compensate this leakage. It will come exactly like this in the administrator screen. Clear?
Kino-compensate kasi.
Yes.
Kaya lang tataas yung value ng tataas yung ano mo gas consume. Yun lang ano nun, effect.
So it's less risk of malfunction with no moving components like the pillow. The pillow, you have the pillows and you have the pillow's cover and you have the O-ring below the pillow and you have the pop-up valve, all this stuff. But here, there is no movable component. You will just unplug this one and send it, for example, to the sterilization or to the autoclave.
And yung gas exchanger.
Plasma.
Yeah, to the plasma even.
So volume exchanger is autoclavable?
Autoclavable, yes.
134.
But to be honest, I'm not recommended to send it to the autoclave. If there is a way to sterilize it, it's much better. But it's autoclavable, yeah.
Plasma is better than.
Yeah, you have to mention the temperature.
134, you will see it later on.
Okay.
So is that clear?
Loud and
Yes.
clear.
Yes, yes.